Hello friends, myself Pratik. In this session we are going to discuss some special points about Naive Bayes classifier. Let us start this session. The first important point to note is why Naive Bayes classifier is called as naive. The answer of this question is that because it assumes each input variable independent from each other. For example, in this dataset we have two classes, two-wheeler and four-wheeler, while we have two input features, that is salary and age. Naive Bayes classifier assume that these input attributes are independent to each other. It means Naive Bayes classifier assume that there is no correlation between salary and age. They are independent from each other. But this naive assumption almost never true. Even in this case, you can see that there is a correlation between salary and age. As the age of person increase, it's natural that his salary will be more. So there is a natural correlation between salary and age, but Naive Bayes algorithm assume that all these input variables are independent to each other. Since this assumption is almost never true, so this is the reason we called this classifier as naive. It is important to note that the assumption which is made by Naive Bayes classifier almost never true, but still it produces very good accuracy and it is considered as very effective technique to solve complex problem. So naive in Naive Bayes classifier means it consider input attributes as independent to each other, and this assumption is considered as naive because it is almost never true, but still this classifier produce wonderful result. The second important point in the discussion of Naive Bayes classifier is about size of the area of marginality. This area of marginality is affecting the value of probability of x and probability of x given two-wheeler. It is important to note that if I increase the size of area of marginality, then it will increase the value of p of x as well as p of x given two-wheeler. Since one value is acting in the numerator while another is acting in the denominator, so its effect will cancel with each other, and ultimately the size of the area of marginality will not be affecting the overall value of probability of two-wheeler given x or probability of four-wheeler given x. The third important point of discussion is about calculating the value of p of x, which is called as marginal probability. So the question is it mandatory to calculate the value of p of x or it is optional? In order to understand this, let us consider our two hypotheses for given example. So in this case, we have to calculate the probability of two-wheeler given x, and we calculated this value by applying Bayes theorem, and this is the formula for probability of two-wheeler given x. Same way we have to calculate probability of four-wheeler given x, and according to Bayes theorem, this is its formula. As we have discussed, then we have to compare probability of two-wheeler given x with the probability of four-wheeler given x. So these two values will be compared with each other. So these two values here we are comparing with each other. And at this point, you can clearly see that in both sides, we are dividing a value with p of x. So here we are dividing this value with p of x, and here we are dividing this value with p of x. Since we are dividing a number with the same value, so here p of x actually cancel with each other. From this discussion, we can conclude that it is not mandatory to calculate the probability of x, because anyway, this is going to cancel when we will be comparing two probabilities. So in most of the cases during implementation, you can see that p of x is not calculated because in both the cases we are dividing the values with p of x and their effect cancel with each other. So we can conclude that it is not mandatory to calculate its value. However, in order to calculate exact value of probability for each class, it is suggested to include p of x. Because if you include p of x in the formula, then only you will be calculating exact value of probability. But for comparison, you can simply ignore this calculation. The third important point which I want to discuss with you is classification of dataset having more than two classes. So we have discussed the case of binary classifier. Here we have calculated the probability of one class given x. Here we have calculated the probability of second class given x by just subtracting the probability of first class given x from 1. So actually there was no need to calculate the probability of second class given x, because only by calculating the probability of first class given x you can decide what will be the winning class. But in case of more than two classes, this is not possible. We always have to find out the probability of at least n minus 1 classes for a data set having n classes with Bayes theorem. Then only we can calculate the probability of remaining last class by just subtracting the sum of all the probabilities of n minus 1 classes from 1. It means that we always have to calculate the probability of at least n minus 1 classes. So if you have 2 classes, you need to calculate the probability of 1. If you have 3 classes, you need to calculate the probability of at least 2 classes. Then you can calculate third by subtracting 1 minus sum of probability of n minus 1 classes. So the important point is this: we always have to calculate the probability of n minus 1 classes for a data set having n classes. So these are 4 important points which I want to discuss with you. In next session, we will be applying Naive Bayes classifier in Python on a given data set. Thanks for watching this video.